in the constellation Cygnus, there's a bunch of variable stars. And one of the ways people name the variable stars is they started counting them. So in Cygnus, the 404th variable star identified is known as V44 Cygni. Now it turns out that this is an object that has undergone explosive events in its past. About 30 years ago, it got very, very bright. And what we thought this was due to was this is a stellar mass black hole, probably around 5 to 10 solar masses, that's accreting from a nearby star. The star is actually not very close to the object, but not very far, so this object has a very large accretion disk. And about 30 years ago, this object went off and underwent what we call a transient event or an outburst. And this outburst was very well studied. The interesting thing is, since then, we've learned a lot about this system. When the star isn't in outburst, when it's in quiescence, we can actually watch the star going around the black hole. So we learn things like the mass of the black hole. We've also been able to take radio observations connecting telescopes around the world, and from that, we're able to look at the position of the object against the sky as we rotate around the Earth using the parallax effect. And from this parallax effect, we're able to measure the distance to this object very well. So we now know that this object is about 7,500 to 8,000 light years away. So here's an object that we know very well. You might say, well, what's the big deal? Well, in 2015, it underwent another outburst. And I, along with most of the rest of the X-ray binary community, these things that study these accreting black holes and accreting neutron stars, we jumped on this object like mad. It turned out that a telescope designed to find the gamma ray bursts from collapsing massive stars or merging neutron stars detected the X-ray outburst from the material dumping onto the black hole. It automatically sent alerts around the world. A radio telescope in England, actually an array of telescopes, automatically started observing it when it came online 8 hours earlier, when the object came into its field of view. From that moment on, we basically had a worldwide sprint/marathon to observe this object in as many wave bands as we could while this outburst lasted. The outburst lasted, depending on how you count the outburst, the most violent parts of the outburst were a couple of weeks, and then it died down over a couple of month period, only to go into outburst again for like a late Christmas present that year, and die down after about a week or two. And so one of my objects as part of sort of this international community was I tried to organize many of us to observe this as much as possible. My own interest, as always, was trying to understand how the matter that is secreting is related to the matter that is outbursting or burping these jets of material. And so one of the things I did is I organized a campaign where we looked with multiple different telescopes, and we took high resolution images of this object over, let's say, 4 hours. And during this, we were able to actually see the evolution of the burping material over 4 hours. We were able to see the individual burps as they propagated out in time due to their proper motion. We were also able to see some other interesting things which we hope to release to the scientific community relatively soon.